So in this section, we're going to talk about solving systems algebraically. Again, this should be a review from what you've learned before in your algebra class, but we need to make sure that we remember all of the steps and processes for this so that we can then apply them in the contextual sense that we want to learn about this semester. So as a review, the point of intersection of two lines is a point xy if that xy point satisfies both equations simultaneously. So the point of intersection has to be true, it has to work in both equations. Just working in one is not good enough. There are three basic ways to find the point of an intersection, and those are graphing, substitution, and elimination. And I'm not going to read through all of the steps of each one. Those are there for you to refer to as you do these on your own. But what I would like to do is just go ahead and solve a system using all three of these methods as a quick review. So the first method is the graphing method. That's literally where you need to get both of your equations in the y equals mx plus b format. So luckily for us, both of these equations are already in that format. Graph them both on a coordinate plane and visually inspect to see where is it that they cross. So that first line is y equals x plus 1, slope is 1, so we start at 1 on the y-axis here, and then we move up 1 over 1, up 1 over 1 to continue finding new points, and we can do that in the opposite direction as well. Connect those, and there's that line. Sorry, it's a little bit not graphed perfectly, but you get the idea. Then the second line is y equals negative 2x plus 4. So that one starts up at 4 with a slope of negative 2 over 1. So we would go down 2 and over 1, down 2 over 1, down 2 over 1. Or we could go in the reverse of that, up 2 and backwards 1, and connect those for the second point. And then what you can see, the point of intersection then is right here. And it looks like it is the point 1, 2. So that is the point that satisfies both of those equations at the same time. Both of those equations equal the same. If you sub in a 1, you will get out a 2. And that's the only place where that happens. Okay, the substitution method is when you solve one of the equations for one of the variables. So you can solve an equation for x just as easily as you can solve it for y, whichever one is easier for you depending on what the equation looks like. And then you substitute that into the other equation for that variable. So we're sort of in luck here because they're both already solved for y. So what we're really going to do is just set them equal to each other. If I have the equation y equals x plus 1 and I replace this y right here with this entire equation, because that's another thing that y is equal to, then what we end up getting is that negative 2x plus 4, because that's a y, is equal to this other y equals 1x plus 1. We can then solve for x. So I'm going to subtract, I'm going to subtract the 1 from both sides. Negative 2x plus 3 equals x, and then I'm going to add 2x. So I get 3 equals 3x, so 1 is x. Once I find the x value, I need to sub that into either one of these equations, whichever one I prefer. I like y equals x plus 1 better because it's less going on. So y equals 1 plus 1, or y equals 2, and that gives me the same 1, 2 overall answer. Be sure to put those in as an ordered pair unless you're asked differently. And then the final method is the elimination method. For the elimination method, we want our equations to actually be in the ax plus by equals c format. So I need to change these. On the first one, I need to subtract the x to the other side, making it negative x plus y equaling 1. And then the second one, I need to add the 2x to the other side, giving me 2x plus y equals 4. And I have to start out with them in that format. And then what we want to do is we want to create opposites, one positive and one negative coefficient for one of our variables, and add them together and eliminate them. So here you have a choice. You could either create opposite x's by multiplying that first equation by 2, or you could create opposite y's by multiplying either equation by a negative 1. It doesn't matter. You should come out with the same answer either way. Just because I feel like it today, I'm going to multiply this top equation by 2, giving me negative 2x plus 2y equals 2. Don't forget this, the number over here, the constant on the other side, the equal to sign. That's the part that if you're going to mess up, students forget that one. And then this other equation stays exactly the same. It's 2x plus y equals 4. Sometimes this is called the addition method because that's what we do next. We add these together. The whole point of this was to eliminate one of the variables, so our x's are now eliminated. We have 2y plus y, so we have 3y equals 6. Y equals 2. And then just the same as the substitution method, once you have your first variable, you want to go back and sub that into either original equation. So I would choose the y personally equals x plus 1 equation again. I would put in a 2 here and arrive that x must be 1. Same answer, 3 different ways. Now we can do these on a graphing calculator as well, and I will show you that in a separate video. So there's a separate video that shows the graphing calculator steps for this.